Hello Patreon members, this is a tutorial video shows how to design a design domain and applying the boundary condition and meshing of a component in order to perform topology optimization process. So I will show you how to create it. This is the end result that the meshing is properly done and the result is we are getting is meaningful one. This is a cantilever I designed, which is a fixed constraint applied here, and this is the load acting here, so it will bend like this on the free end. So the meshing is okay, we can perform the FE analysis. In order to do this, there is a specific step. So these are the steps that is applied for the CAD section, and these are the steps for applying the meshing section. So I will show in a separate document how to do this. I will copy the sketch, these two sketch, because sketching from scratch will take some time. So I'm copying the sketch. So I copied the sketch to a new document. If I highlight this sketch, this is the free section sketch, and this will be the sketch for the fixed domain. So firstly, what I will do is I will extrude the sketch and then extrude the sketch 001. So going to the part module, you can do the sketching here with this workbench. I'm going to the part section in order to extrude the already prepared sketch, clicking on this icon, and instead of 10 I am giving 5. Then I'm extruding along normal, it is okay. Then taking the next sketch, which is the sketch for fixed domain or fixed region in topology optimization, where the elements will not be removed from that space. So again the similar procedure, go to the extrude button, change the value to 5 along normal, okay. So we got a 2 objects, and we had first next thing we have to do is select the both objects. Then go to this icon, boolean fragments. So click on this icon, and from this boolean fragments there is a data icon is here. From this, under the boolean fragments, and from the mode section, select the solid, means composite solid. Then from this, the next step is to go to part module, then select the compound filter. So we have to select the boolean fragments before going to that, then go to the compound filter. So the CAD section is over. Next we have to move to the mesh section, that is FEM. Firstly we have to click on this activate this analysis section, then right click, then activate analysis. Then we have to apply the constraints. So these two surfaces will be fixed in this case, and applying the load by selecting this surface, and the direction will be along this direction, selecting a edge in that direction, and the value that I will give 1000 Newton. You can give whatever the value you want. Then the next thing is assigning material. So I will give calculix steel. And what is the purpose of doing these boolean fragments and compound filter is, you can see now, you can split the solid objects. So by clicking on this add, I will select the free region. So you can see the solid one, then press OK. So the solid material is assigned to only this region, this highlighted region. In the next step we will select the material, the same material, to the different three solids, that is solid 2, solid 3 and solid 4. Okay, so this material is assigned to this region. Why we are doing this? This is only for just to get a group of node. In performing optimization, we have to give algorithm that this region has to be excluded. So in order to extract the group, we are creating this step. Then the next thing is to mesh the object. So for that we have to click on this compound filter, go to the gmesh icon, and firstly we have to apply OK. Then again press this FEM mesh gmesh, go to this region, create a FEM mesh region, click on that. Let's say 2 maximum element size. Select the free region first, add free region, that is solid 1. Press OK. Again press on this FEM gmesh icon, then select the FEM mesh region again, the maximum element size 2. Then by selecting solid, we have to add the 3 solid region. This will act as a separate group. So there will be 2 region. Now what we have to do in order to mesh the object, double click, click on apply, the mesh will generate. It will take some time. Yeah, you can see the boundary is, we have to hide this in order to see the clear boundary. So this is a circular section where this region we can isolate from this the remaining region where the optimization will takes place. So here also you can see, so this is the step. And in order to check whether the meshing and every process is okay, what we have to do is, in this FreeCAD section, double click on this icon, write .imp file. It's completed. Run calculix. It will run in the background. Once it ends, it will throw the result into the user interface. So the calculix done without error. Close this. In order to view the result, double click on that icon, and this is the absolute displacement. This is the one meter stress. You can check this animation of displacement. In order to get the much more clarity result, what you have to do is click on this calculix static result, then go to this icon. If you click on it, a pipeline object will create. Double click on it, then from this select surface, select the stress vectors. You can see the clarity in the result. If you want to see with edges, or if you want to, this is, I think it is a VTK object, which you can see in similar to in ParaView. So it's a wireframe view. Like that you can check different options. So this is the step for creating deleting this pipeline object. Up to this meshing and creating this INP file, I will show the topology optimization process using calculix solver. So I will use the .imp file format. So in order up to creating this IMP format, that is the step included in the pre-processing stage in this FreeCAD point of view. Next, I will show how to generate a similar kind of pre-processing steps using the open source pre-processing meshing package called Salome.